If you're seeing my screen, you're seeing question number 1 there. And this is called vertex form. Hopefully that was covered in class. It's the form ax minus h squared plus k. It has a vertex at h comma k. So it's this number if that's negative. If it's positive, then you have to, it's negative of that. It's always that number.
Okay.
And the vertex is either the min or the max. It's the min if the parabola opens up, and you know that if a is greater than 0. It's the max if the parabola opens down, and you know that if a is less than 0. A is never equal to 0. So you always have that happening here. So essentially, you have to put a dot where the vertex is. So the vertex of this one is 4 comma negative 3. Is that clear from this? Because h is 4 and that's negative 3. So if you were to graph this, let's say here's my origin, I would go 1, 2, 3, 4, and then down 3. And then a is 1, that's a. So I know it opens up like that. It looks something like that. Okay. All right. Question number 2. We'll do the same thing. I know it just wants you to compare them, and maybe you'll get a multiple choice test like that, but you may also in a future class be asked to do this without a calculator. So now let's see what got here. So try to tell me the vertex of this one, please.
So the vertex would be 4, 3.
It is 4, 3.
Yeah.
Very good. Okay. And this time a is negative 1, so we know it opens down. So I'll put my origin there. 1, 2, 3, 4, 1, 2, 3, and then this U-shaped thing like that going down. Oh, so they give you a bunch of these that are very similar. Okay. Well, these are going pretty quick. Okay. So this one, the vertex is a little bit different. It's now at negative 4 comma negative 3. So what some students remember is it's opposite of this number here. I prefer to think about what number makes this whole thing 0. But it's either the opposite of this number, what makes the whole thing 0, but it's always that number. A is equal to 1, which means that it opens up. So we go 1, 2, 3, 4, 1, 2, 3, and then this thing opens up something like that. Okay, and last one here. All right, so here the vertex is at negative 4 comma 3. The a value right there, a is equal to negative 1, so we know it opens down. I maybe should have mentioned this before, like that means it has a min. Since this one opens down, it has a max. So we're just creating our origin here. So we got 1, 2, 3, 4 left, up 3, but it opens down, something like that. So it's got a max. Anything you'd like me to make clear on that?
Those ones make sense.
Okay. So it jumps to 9. Is that right?
Yes.
Okay. All right. So the there's a couple of ways to do this next one. One is completing the square. Okay. I don't know if that was covered in class.
Yeah, we went through that a little bit today.
Okay, and that's a skill that's often learned and then forgotten.
Yeah.
The other one is the other approach here, and this is why I gotta ask, is you determine the vertex through formulas, and then you use the result of that to write in this form. So my question to you is like, do you want to do the completing the square, or do you want us to use formulas to do this I think at some point you will have to complete the square, but it's also it's also something that I don't, it's up to you. It depends on what you think you'll see in class.
I think we have to complete the square for these. I think that's what she said.
Okay, so I'm just gonna bring this down. X squared minus 6x. And normally there's a number here, like it's like plus 10. And you bring that number to the other side over here of the equation, but it doesn't exist. So there's nothing there at the moment. Okay. And this quadratic equation has to form ax squared plus bx plus c. But a is 1 in this case, okay, which is good for us because we're trying to learn how to do this. The first thing you do here is you bring this thing down, but you cut it in half. So what is half of -6?
-3.
You bring this x down, so you're at x minus 3 squared. Now, if we come off to the side here, and I asked you, what is x minus 3 squared? You would say it is x minus 3 times x minus 3. And that's x squared minus 3x plus 9, x squared minus 6x plus 9. How does this, what I've written down here, compare to what's up here?
We have the 9 now, and there's
there's no 9 here, right? Would you agree with that? Yeah. So but there should be a 9, right? So this is a balancing thing. So if there's a 9 here, there has to be a 9 here.
Okay.
It's like you and your brother, depending on your family, how your family works, but sometimes you get a gift and he gets a gift. You get to play. It's a equal here. So the next step here is to bring this 9 down. So you have this x minus 3 squared equals 9, and then you subtract 9 from both sides. So you get x minus 3 squared minus 9. And then if you go back up to the top, see how it said p of x, you just bring that down. You just say, oh, it's p of x equals that. Okay, now I don't expect you to be able to fully understand that, but I do want you to tell me what the vertex is of this one, please.
The vertex is 3, -9.
3, -9. Yes. Very good. And does this open up or down? It opens up, which means it has a min or a max?
A minimum.
Min. Very good. Okay. All right. So this question here, it says, write it in this form. So we did that. That's part A. Part A is right there, if you're keeping track. B is the vertex, and then graph the function. So 3, -9, I don't really like that, but that's what we got here. So that's my origin, 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, and it opens up. So I don't know how exact you have to be with that, but something like that.
Yeah, I don't think she wants it too exact. I don't think she really cares.
Yeah, they're looking for, like, does it open up? Does it open down? Great. Okay, so let's move to number 10. Is that okay?
Yeah, that's fine.
10's a good one to move to. It's actually a nice extension from 9. We'll have to do a few more of these completing the squares. Is that a plus on your side? It looks like a plus there.
I don't know. Now that I look at it, it has like a very minimal plus sign. I thought it was a minus, but
I'm gonna go with plus. It does change this a little bit because it affects the number. So the very first thing you do is you can ignore this for the moment, is you take half of this number. So half of this number is 2. When you square this thing right here, what number goes here? When you expand this binomial, when you write x plus 2 times x plus 2,
it'd be 4.
Plus 4, right? So to be fair, you have to give it to both sides. does that make sense? Like if you put it here, you have to also put it here. And that's why I put the lines there like that so that you see that. Okay. Notice if you subtract 4 from both sides, you get back to the original, which is what is supposed to happen. So you currently have x plus 2 squared equals 4. You do subtract 4 from both sides, but you don't do it in this expanded form. It's in this vertex form. Okay. And then you bring this p of x down. Is that okay?
Yes.
All right. So give me the vertex of this one, please.
The vertex is -2, -4.
Very good. All right. And then does this open up or down?
Down. Oh wait, no,
Up.
up.
Up. And does that mean it has a min or a max?
A min.
As a min. All right. So -2, -4. So if here's my origin, -2, 1, 2, 3, 4, and then it does something like that. Okay. All right, this is a spot where I'd like to give you a question that's not on your homework. We have plenty of time to finish, but let me give you one that's a little bit more likely to see. Okay, so they'll give you something like this, and they'll say it'll say to write in vertex form by completing the square. CTS, completing the square. So I mentioned like you actually want to move this to the other side first. And the number that you put here ends up going over here also. So see if you can carry this out on your own. I think you can, but give yourself at least a minute to work through that.
Okay.
And see if you can come up with an answer for me.
Is it x -4 squared plus 6?
So this is x minus 4 squared for sure. Okay. So now what number goes here when you expand this?
-6.
The -6 is over here. So forget about that. I'm talking about like what I'm really asking is what is x minus 4 times x minus 4? And you're going to say it's plus 16, I think. So if you add 16 here, you have to add 16 here. Do you see that?
Oh yeah.
Okay. So then so this is where these three terms become this right here, this binomial. But on the right, you have to add them together. So that equals 10. So if you subtract 10 from both sides, you get back to x minus 4 squared minus 10. And that's your p of x. So what we have from the start here is this down here if you expand it and subtract 10. Were you able to write this down? Because I want to give you one more example, and I can scroll up if I need to, but I need a little more room to write the next.
Oh no, I have it all written down.
Okay, excellent. Okay, so let's say f of x equals x plus, x squared plus 6x minus 3. Okay, I want you to complete the square on this one, please.
Is it x plus 3 squared minus 12?
That sounds pretty good. So here's what I'm going to do. I'm going to move this. I'm going to add 3 to both sides, even though there's not a both sides. Now there is. So there's a 3 and a 3. And then you write x plus 3 squared because half of 6 is that. Okay, so you square that and you get plus 9 equals 12. So you get x plus 3 squared minus 12. And I think that's what you said. Is that right?
Yes.
Okay. Would you like to do one more like this one or move on to a more difficult example?
We can move on.
Okay. We're going to move to 14, which it actually has like two kind of level increases in my opinion. But if it's not clear, we can do another one like it.
Okay.
So again, like these don't have that plus C, that third number here, but it's okay. I mean, but this one's got something different and it's got this -4 here. So I don't see, I don't actually, I probably don't do this exactly the way you're going to see in class, but you may find that you like this way better.
Okay.
Okay. So notice I don't put anything here,
Mhm.
but if I distribute this in, do I get back to the original? That's the question for you. Does that get me back to the original?
Yes.
Yes. Okay. Now this one's a little bit awkward, but what is half of -1?
-1/2.
So it's -1/2 here. So it doesn't matter what it is, you take a half of it. Okay, you have to bring this -4 down. Now, if you square -1/2, what number goes here?
1/4.
Yes. Okay. And here's the problem is you don't put 1/4 here. And this is what's different about it. When you distribute this in, what goes here when you distribute this in for this last one?
-1.
-1. So you need to subtract 1 from both sides. See how these have to match?
Oh, yeah.
So there's a -1 here. So this equals -1. So then you add 1 to both sides to bring it back over. And you get -4x minus 1/2 squared plus 1. And that's your P of x here. If you truly understood that, you understand the most difficult type of problem you might see.
It makes sense. It's just a little more.
Yeah. Let's do one more. Did you get these notes down? I can scroll back up if you didn't, but I'd like to write down the next example. Okay. So let's say P of x equals -2x squared minus 2x. And I guess we'll leave it at that because that's kind of how the last example was. So give this one a try and then I'll work through it and you can see if you got the right answer or not.
Is it 2 times x plus 1/2 squared plus 1/2?
Should be a negative as at some point here. So let me,
yeah, I did not see that.
so let me just go ahead and do a few things here. Let me get rid of this. So I leave there's a space here and there's a space here and a space here. So we take half of this number, which is 1/2. So again, this is 1/4 again. But when you multiply the -2 in, you get -1/2 there. Do you see that?
Yes.
So you have to put that -1/2 there, -1/2 there. So you bring this -2 down equals -1/2. -2x plus 1/2 squared, and then you add that to the other side there. Okay. You might want to ask your instructor and say, hey, Mr. Instructor, Mrs. Instructor, I I have, I want to know, I was working through these and like 14 seems so much more difficult than the other ones. Will this be on the test or will they be more like, 10, 9 and 10? I'll bet you'll find that they're more like 9 and 10.
Mhm.
Okay, so I think there's a couple more questions on the um, this thing here. The graph left of 23 is cut off kind of ish. It's not easy for me to read either.
I think it says
Looks like it's x plus 3 squared minus 4.
for 23, I think it's -2 times x plus 3 squared plus 2.
Yeah. Do we need to do both of them or just 23?
We could just do 23.
Okay. Great. So there's a long list here of things, and it could seem like, oh no, there's so much to do here. There kind of is, but it's all stuff we've probably already talked about, and some of them are like one-line answers. So sometimes instructors get away with saying, oh, it's not that much homework because
Mhm.
there's a lot here. So A is asking for the vertex. Okay, so give that a shot, please. What's the vertex?
The vertex is -3 and 2.
Very good. Okay, so we're gonna go to C next. We'll come back to B. We're doing C next because it follows from the vertex. The axis of symmetry is always x equal that number right there.
Mhm.
So it's
So
always going to be that it's really like x equals h.
yeah.
Okay. All right. So the domain and range, we'll do that up here. The domain is always all real numbers, always. Are you using interval notation or something else?
I have no idea. She didn't really go over what she wanted for the domain.
So sometimes instructors say like x, such that x is an element of the real numbers. Some say ARN. This is completely weird and wrong, but this is where you're going.
Mhm.
The domain is always all real numbers. All right, the range it depends on whether it opens up or down. And I know this one opens down, but I want to give them both to you. So when it opens up, it's the value of k to positive infinity. K is that. And when it opens down, it's minus infinity to k. So since this one opens down, it goes down to minus infinity. And the k value is this positive 2. And it includes it. It always includes it. Is that okay? Any questions on that?
No, that one makes sense.
Okay, so the next two are increasing and decreasing. So it's actually kind of like the last one we did. It's increasing if it's going up and
Mhm.
to the right. And so that's something that if it looks something like that. Now, I'm gonna actually copy this back in because I want to color in the graph here. So I'm going to do this in red. Sorry for it being in red, but that's what it is. It's red here because it's going up and to the right.
Mhm.
All right, so that's minus infinity to this x value here, minus 3,
Mhm.
because so increasing is always x values,
Mhm.
and same thing with decreasing. It's where is it increasing, not what is it increasing to. It's just a where. All right, and then let me do the decreasing one. So decreasing, sorry for not writing it all. Decreasing is going down and to the right. Okay, so that's something in blue here, And that's this region here. It's always going down and to the right there. So we would say -3 because it's the x value that we care about
Mhm.
to positive, because everywhere to the right, it's decreasing. Okay. The next question, part of the question is state whether the vertex is a maximum, minimum, and give this corresponding maximum. Okay. So we've already kind of answered this. It has a maximum,
Mhm.
and maybe I should just copy this. Grab that, get this down here. Okay, so this one has this is the place right here. So it has two parts. It has a max of 2 at x equals 3. So that's the y value, and then that's the x value. But you have to write it in a sentence. Like the function has a maximum of 2,
Mhm.
and you can think this is the where. Where is it? So think of wherever you live, but you live on a street. I
Mhm.
live on whatever street. Where is it? And then what do you live in? Like some people live in a house, some people live in a condo.
Mhm.
You know, if you live in a city, you live in a tall building. And that's what the difference is. Where is it and what is it? It's kind of two questions. All right. So that closes out 23 there for you. Okay, so we have some more time. Some options include completing the square. I've got a question of the week we can look at for SAT, ACT prep, or anything else. Obviously, you'd like to work on. You're the customer, so whatever you think is
Um,
best use of your time for today.
Maybe we could do more completing of the square because we just learned that today.
All right, let's do a few examples here. So let's say f of x is x squared minus 10x minus 24. Okay, and the question would be, it might say to complete the square, it might not, but we're just going to assume that that's what we're doing here. But the goal is to get the vertex. So this is a little bit different than the ones that you've been doing. The first step is to make an equal 0 and move this 24 over. And I'll let you take it from here, please. I'm sorry, let me make that plus 24. So that's minus 24.
So would it equal x minus 5 squared plus 1?
Yes, exactly. So x minus 5 squared, that puts a 25 here, puts a 25 here, equals 1, and you bring it back over, and that's your f of x. Okay. All right. So now here's kind of this intermediate one that I think is important to give. Let's say I tell you that f of x equals minus x squared minus 4x plus 3. Okay. And the one you were given in your assignment didn't have this, but the very first step, whenever you have a number other than 1 here, you always move this negative over.
Mhm.
Okay, so or this number over. So it's going to be either that you set it equal to 0, so you have minus x squared minus 4x equals -3. What I like to do is factor out this negative first. Okay, so I always bring it back to that form that you were doing in the previous problem. So here you would write like x plus 2 squared and bring this negative down.
Mhm.
So what goes here?
-4.
-4 goes here, but here it's
Wait, now
positive
it's
4.
4.
Okay, so what do you put over here? You put -4 because these are the ones that have to match.
Mhm.
It's very easy to do what you said and just get the wrong sign on it. All right, so do you have all this down? Because we're going to do one like it that will help you with your understanding of this.
Yes, I have that all down now.
All right, so let's say f of x equals negative x squared plus 6x minus 5. So go ahead and give that one a try, please.
Is it negative x minus 3 squared minus 4?
It's plus 4.
Oh,
Okay, so let me run through it here and see if you can find your mistake. So I move this over first, so it's minus x squared plus 6x equals 5. Then you factor out the negatives, so it's x squared minus 3x here equals 5. This collapses to, oh, did I choose this? Oh, I'm sorry, I wrote the wrong thing there. So there should be a 6. Sorry, I was like, that doesn't look right. Okay, x minus 3 squared. This becomes plus 9, but then you negate it there because when you drop
oh,
the negative in, and that's what's confusing about this is this extra line here, minus 9 equals minus 4 plus 4.
oh,
I'm sorry,
okay.
let me get rid of that. And so it's so f of x equals minus x minus 3 squared plus 4.
Okay. I don't think I made it plus 4 when I moved it over because everything else seems right.
Let's try another one here.
Okay.
Say f of x equals negative x squared minus 8x minus 9.
Negative x plus 4 squared plus 7.
That's looking pretty good. Yes, that is correct. Okay. Yeah. All right, let's do another one here. That's maybe the only increase in difficulty is putting a number other than one negative one in front. So let's try another here. Let's go negative 3x squared minus 12x and then a minus 24. Do that.
I got -3 times x plus 2 squared plus 12.
Okay, so what number did you put here? So
Oh, I did not move the 24 over first. That's what I messed up.
yes,
I divided it all by 3.
yeah, so I mean, this ends up giving you 4, and then this gives you -12, -12, -12. So this equals 12, and then you move it back over and get -12. There's a lot of steps here. None of them are difficult because they're all just either adding or subtracting. Okay. Would you like one more like this or move on to something else?
Oh yeah, we could do one more of that one.
All right.
So you have to move the c over before.
Yes. Now, not everyone teaches it that way, but that's my preference for it. All right, so there it is.
Okay, I got -4 times x plus 3 squared plus 19.
It's looking pretty good. I'm just you said I'm gonna make sure I heard what you said here. -4x plus 3 squared plus 19.
Yes.
Okay, that's not quite right.
Oh,
So let me just move this off to the
where I
side.
messed you up.
So again, yeah, you want to move this over. So it's -4x squared minus 24x equals -10 because
Okay.
you're moving it over. Factor out the -4, x squared plus 6x. Okay, and then I mean this is where I think it gets potentially confusing.
Yeah, I think this is
Okay,
where I messed
so
up.
you figure out what number goes there. Well, it's +9. Then you multiply this -4n, so it's
Oh, I haven't been multiplying first.
yeah, and then you
Okay.
get this, and then you get -46. So you
Okay.
get
Oh no, I
-4.
moved the 9 over. I forgot to multiply it by 4.
All right, is that okay?
Yes.
I would suggest either looking at the notes or the video later on if you have more questions about it. So anything else come to mind for something you'd like to work on in class?
I don't think so. Since we just started a new unit, I don't really have much right now.
Okay, so alternatively, so here's some options. We can stop here. I've got a question of the week. It's totally up to you, whatever you'd like at this point.
Let's see. Let's see if I have anything else. Oh, I did not send this to you, but on the back, I had a question. I'll try to send it to you right now.
Yeah,
But
we've got enough time. Go ahead and just email it
okay.
over if you can, please.
So I found it, you have to find the vertex and then graph it, and then she likes us to check our answers with our graphing calculator afterwards. And so I found the vertex, but then when I plugged it into my calculator, it was not the right thing. I'm sending it over right now. I think it's sent.
All right, checking here. Got it. Okay. So 27, you said?
Yes.
What are the instructions here? I'm sorry, I didn't quite follow.
So you just have to find the vertex and then graph the function.
Okay, so we're gonna just complete the square. You've already done a couple of these, so just given the shortness of time, I'm gonna run through it just to make sure we get it all
Okay.
done here. This is one of those where again you move that number over. You imagine there's an equal 0, so you put a 2 over here. You factor out the negatives. So it's x squared minus 4x equals space here. And then you've been doing this step really well. You know to put x minus 2 squared. Bring the negative down, plus 4. But when you multiply the negative in, you get minus 4 up here. Minus 4, minus 4. So this equals minus 2. And then you bring it back over. Okay, so that's the vertex form. And then the vertex here is 2 comma 2.
Okay.
And then
I don't know how I got 10 because for the backside to find the vertex, she said we could use negative b over 2a to find the x value and then plug in that to find the y.
So if x is 2, then y equals, like you just said, it's negative 2 squared plus 4 times 2 minus 2. So the mistake is likely here. Sometimes students think, oh, I put it in here, but you negate afterwards. So it's negative 4 plus 8 minus 2. It ends up being 2, mapping back.
Okay. I did not add the negative, but okay.
This is, I mean, I would love for you to, go to my YouTube channel and click on this link to watch the video. Again, this is the one time I really actually think you really would benefit from seeing this. It doesn't have to be today, but at some point, go back and just maybe watch the section on this and see if you can work through the problem. So this is a great place for us to stop. Thank you for scheduling. I'll send you the notes and their screen recording out shortly, and I'll see you next time.
Perfect. Thank you.
You're welcome. Bye now.
Bye.